All right, sixth graders, welcome to another video tutorial. Today's topic is prime factorization. Yes, that's what we're going to talk about today. So get out your composition book, get a pencil, get a pen. We're going to take some notes, all right? Video tutorial should not take that long. Prime factorization. We're going to learn something that looks like this. Watch, I will do 8 times 8. Yep, that's 64, right? Okay. And then 4 times 2, yep, because that's 8. And 4 times 2, yep, because that is 8 as well. And then 2 times 2, and 2 times 2. And then eventually I would write this maybe 2 to the 6th power. And we'll talk about how did I do that? What does 2 to the 6th power mean as well? But some people, when they think of prime factorization, they think of what does that look like? A Christmas tree. Oh, isn't that nice? Okay, so anyway, I digress. Let's move on. All right. So we're gonna just talk about prime factorization. First of all, what is a prime number? I think some of you remember, what is a prime number? And what is a composite number? Remember we used to play Cheeseburger in Paradise with this? And we'll probably play it some more. But prime numbers are, write down your definition if you know. And composition numbers are, write down your definition if you know. Go ahead, press pause, write down. Did you write down? Did you write something like this? A prime number is a number that only has 2 factors. That's it. Such as like 11. The only 2 factors, numbers you can multiply to get 11 is 1 and itself. That's a prime number. Yeah, no other factors. Another example of prime number is 13. Okay, a lot of students think all odd numbers are prime numbers. Well, that's not true, because think about like 9. You have 1 times 9, well, there's 2 factors, but then you also have 3 times 3. So not all odd numbers are prime numbers. But there's only one even number that's a prime number. That would be 2. 2 is the only even number. Why? Because every other even number is divisible by 2, right? So anyway, prime numbers, only 2 factors. So composite numbers are not prime numbers. They are numbers that have more than 2 factors. So they have 3 or more factors, like 9, 1 times 9, 3 times 3. Like 25, 1 times 25, but 5 times 5. Like 32, 1 times 32, 8 times 4. Is there anything else? Oh, 16 times 2, right? So anyway, what are prime numbers? What are composite numbers? Write this information down. If your definition is not kind of similar to this, write this information down. So what does it mean to prime factorize a number? Well, it just means you are going to keep factoring the number until you have all prime numbers. For example, when you look at this Christmas tree that I made, I factored it here, 8 and 8, but those aren't prime numbers. So I factored 8 again. Okay, I factored to 4 and 2. Well, 2, that's a prime number. So I stop with that one because it's a prime number. Can't go any further, right? But I can factor 4. So I factor it to 2 and 2. Okay, so I stop and I stop. I stop and I have all prime numbers. So prime factorization is just factoring a number until you have all prime numbers. And then you write out its product. So for example, if you look at 18, if you would write as a prime factorization, it would be 2 times 3 to the 2nd power. And remember, 3 to the 2nd power just means 3 times 3. 3 to the 2nd power. So how did I get this? Well, if I prime factorize it, or do the Christmas tree, I could say like 9 times 2. And I would stop now here, because this is a prime number, but I still can factor 9 to 3 times 3. And so now I have all prime numbers. See that? And so I would say 3 to the 2nd power, because there's 2 of them, times 2. Forget that I can just touch this and use my fingers. That's pretty cool. My new Promethean board. I like it. 36. Okay? So if I factor 36, I could do it several ways. I mean, somebody could say 6 times 6. Sure. Somebody else would say 9 times 4. Sure. Somebody could say 18 times 2. It doesn't matter. you're still going to end up with the same results at the end. So let's just do 9 times 4. Okay, 9 times 4. And then I could factor this to 3 times 3 and 2 times 2. And again, you stop when you have prime numbers. When you have a prime number, the branch of that Christmas tree has now stopped. Okay? So then I would write out my prime factorization, which would be 3 to the second power. There's 3 to the second power times 2 to the second power. Okay? So when over here, when I got 2 to the 6th power, that really means we're taking the number 1 and we're multiplying it by 2. How many times? 6 times. That's a little review. So 2 to the 6th power is really 64, because you would do 2 times 2, 4, times 2, 8, times 2, 16, times 2, 32, times 2, that's 6 2s, and I got 64. See how that works? It's pretty cool, huh? There's another method. I always like to use the Christmas tree method. I do. I like that method a little more, but I see some students, they'll use this method over here. Look what they're doing. So they're just taking 60 and they factor out a prime number. They do 2, and so the 2 times what? They put 30. And they factor out another 2. 2 times what? 15. Then they factor out the 3. 3 times what? 5. And then they write their prime factorization as 2 to the second power. You can see that right there. Times 3 times 5. Both ways work. I just like the Christmas tree one more. Let me do however you want to. Okay. I don't think we have anything else. Let me just see. Oh, so let's just do some practice problems. So in your composition book, write down these 4 problems and prime factorize it. Use either method. If you need to, go back and look at the 2 methods. Okay? And remember, you keep factoring and factoring and factoring until each of those numbers are prime. Then that branch of the tree is done. You can't factor anymore. You can't factor anymore. That's it. So this video tutorial is a little bit longer, about 7 minutes, 8 minutes longer. I hope you enjoyed today's lesson, and I'll see you guys tomorrow. Bye-bye.